AI, artificial intelligence in 3D bioprinting.
Artificial intelligence in 3D bioprinting involves the use of algorithms to optimize the bioprinting process and create complex tissues. This technology combines artificial intelligence, machine learning, and tissue engineering to achieve precise results. By utilizing AI, researchers can improve the accuracy and efficiency of bioprinting, leading to advancements in regenerative medicine and personalized healthcare. The integration of AI in 3D bioprinting is revolutionizing the field by enabling the creation of intricate and functional biological structures.
Everyone seems to be talking about AI and the human's impending extinction at the hands of Skynet. Formulations could be made based on the desired characteristics. For example, a material developer selects a few ingredients and defines the mechanical properties that new material should have.
Hi there. I'm Elena, a machine learning engineer specializing in AI and bioprinting. How can I assist you with improving tissue cell placement accuracy in 3D bioprinting?
Hi, nice to meet you, Elena. It's a great pleasure communicating with you today.
Nice to meet you too. How can I assist you with your bioprinting project today?
My name is Senthil Kumar. I work for a hospital in Chennai. We recently purchased FDM laser 3D printer which can able to print tissues.
Pleasure to meet you, Senthil Kumar. How can I help optimize your tissue printing with AI algorithms?
Can you explain how I can implement machine learning in order for stiffening my tissues which going to be put inside the brain, which recently we are going to do head surgery.
Absolutely. We can use machine learning to optimize the stiffness by analyzing tissue properties, predicting optimal printing parameters, and real-time monitoring. Shall we start with data collection?
Yes, please, maybe you can guide more from ML point of view as being you are a specialist. So what are the things need to do for the data gathering?
Of course. To start, you'll need 1. High-resolution imaging data of brain tissues. 2. Mechanical properties data, stiffness, elasticity. 3. Printing parameters, speed, temperature, material composition. 4. Patient-specific data for personalized optimization. Ready to proceed?
Thank you so much for providing me the info. I have a DCOM and as well as MRI scan data. So how you can make use of those available scan images of the patient?
Great! We can pre-process the DICOM and MRI scan data to extract relevant features. These features can train our machine learning model to predict the optimal printing parameters for personalized tissue stiffness. Shall we dive into pre-processing?
Yes, please.
First, we'll convert the DICOM and MRI scans into 3D models. Then, we'll segment the regions of interest, such as brain tissues. We'll extract features like tissue density and structural characteristics. Ready for the next step?
You are awesome. You are giving me lots of data and information which first time I'm hearing it. Yes, please proceed.
Thank you. Next, we'll label these features with their corresponding mechanical properties. This labeled dataset will train our machine learning model. We can then validate the model with a subset of data. Shall we set up a pipeline for this?
You are wonderful. So you are leading me in a more process way. Please go ahead.
Excellent. We'll use Python and libraries like pydicom for DICOM handling, NumPy for data manipulation, and TensorFlow for model training. We'll also need segmentation tools like ITK-snap. Shall we start with setting up the environment?
That's great. Please do so for the next steps. You are very helpful in explaining slowly as well as deeply on the subject matter.
I'm glad to hear that. Let's begin by setting up your Python environment. Ensure you have Python installed, then install the necessary libraries with bash pip install pydicom numpy tensorflow xsnap ready to install.
Yes, ready. So I can listen from you first, then later maybe I have my colleagues who can guide me in the actual process. Please go ahead in explaining the steps.
Perfect. Here's a simplified step-by-step outline. 1. Install libraries. Use the command I provided to install necessary libraries. 2. Load DICOM data. Python import pydicom dataset equals pydicom.read path underscore to underscore DICOM underscore file.dcm. 3. Convert to 3D model. Use ITK-snap for segmentation and then export the 3D model. For extract features, Python hashtag example, extract pixel array and calculate density pixel underscore array equals dataset dot pixel underscore array density equals np.mean, pixel underscore array. 5. Label data, manually label the mechanical properties like stiffness. 6. Train model, Python import TensorFlow as tf model equals tf.keras sequential, tf.keras.layers, dense, 64, activation equals relu, input underscore shape sadface input underscore shape, tf.keras.layers dense, 1, model.compile, optimizer equals atom, loss equals msc, model.fit, training underscore data, labels, epochs equals 10, 7. Validate model, use a validation set to ensure accuracy. Does this outline make sense for your next steps?
it really makes sense to me. Yeah, please go ahead for the next steps.
Great! Next, let's dive deeper into each step. 1. Install libraries. Bash pip install Pidicom numpy TensorFlow 2. Load DICOM data. Python import Pidicom import numpy as np dataset equals pidicom.pred path underscore to underscore DICOM underscore file dot dcm pixel underscore array equals dataset dot pixel underscore array 3. Convert to 3D model. Use ITK-snap to manually segment the regions of interest. Export the segmented data as a 3D model file, e.g., Nifty. For extract features, Python hashtag example, calculate mean density equals np.mean, pixel underscore array, hashtag. You can also extract other features like texture, shape, etc. 5. Label data, collect mechanical properties such as stiffness for each tissue sample. Create a dataset with features and corresponding labels. 6. Train model, Python import TensorFlow as TF from sklearn.model underscore selection import train underscore test underscore split, hashtag. Assuming you have your features and labels x underscore train, x underscore val, y underscore train, y underscore val equals train underscore test underscore split, features, labels, test underscore size equals 0.2, model equals tf.keras sequential, tf.keras.layers dense, 64, activation equals relu, input underscore shape sad face x underscore train dot shape, 1, comma, tf.keras.layers dense, 1, model.compile, optimizer equals atom, loss equals mse, model.fit, x underscore train, y underscore train, epochs equals 10, validation underscore data sad face x underscore val, y underscore val, 7. Validate model, Python hashtag evaluate model performance loss equals model.evaluate, x underscore val, y underscore val, print, f model loss. Now, you have a trained model that can predict the optimal tissue stiffness based on patient-specific data. How does this detailed breakdown look to you?
Yeah, can I ask you some basic questions? So, what is the name of machine language algorithm that you are using it at this moment?
Certainly. The basic machine learning algorithm we're using here is a neural network, implemented with TensorFlow. Specifically, this example uses a simple feed-forward neural network, or multi-layer perceptron, for regression tasks.
Are there going to be any cloud solutions like Google Cloud or AWS or Azure for our project?
Absolutely. Cloud platforms like Google Cloud, AWS, and Azure offer robust solutions for machine learning projects. You can use 1. Google Cloud AI Platform, BigQuery, Compute Engine. 2. AWS, SageMaker, EC2, S3. 3. Azure, Machine Learning Studio, Virtual Machines, Blob Storage. These platforms provide scalable compute resources, storage, and pre-built machine learning tools to streamline your project. Would you like guidance on setting up a specific cloud platform?
Yes, please. Can you provide more details on Google Cloud platforms? So, what would be the best platform engine that we can use for this project?
Of course. Google Cloud provides several powerful tools for machine learning projects. Here's a step-by-step guide to using Google Cloud AI Platform for your project. 1. Set up Google Cloud account, sign up for Google Cloud and create a project. 2. Enable APIs. Enable the AI platform, compute engine, and cloud storage APIs. 3. Install Google Cloud SDK. Install the SDK to interact with Google Cloud Services via command line. Bash curl https://sdk.cloud.google.com /cloud init 4. Create a cloud storage bucket, store your data and trained models. Bash sudo mbgs // your bucket name 5. Upload data, upload your training data to cloud storage. Bash sudo cp local data path gs // your bucket name 6. Create a Jupyter Notebook instance, use AI platform notebooks to
Thank you. Definitely, it helped me.
I'm glad to hear that. If you have any more questions or need further assistance with your project, feel free to ask. Good luck with your bioprinting and head surgery project.